So let's start question number 3. In question number 3, one set A is given to us. So I have rewritten here this set A. Set A is equals to this 1, 2, 3, comma 4. One set is an element and then 5. So which of the following statements are incorrect and why we have to mention here? So first of all, you have to remember one thing. This symbol we use for subset, not for element. And this symbol we always write for element. And set is always written inside the curly braces. Now A set is given to us and I have written its elements like this. So elements of A are these. So these all are elements. So why I am writing this like this? Because you always have to remember this thing. For elements we use this word belongs to. So 1 is element of A, 2 is also element of A. This full set 3 comma 4 is element of A and 5 is also an element of A. So first one is 3 comma 4. See 3 comma 4 how I have written 3 comma 4 is what? This is an element of A. So element I have to write it as belongs to. Element, this is very important thing. Whenever we are writing element should be written with this symbol. So it should be given to us that 3 comma 4, this set belongs to A. So that means first one is incorrect because it should be written this way. It should not be written with the set symbol. So this is incorrect. I will be just writing it as false. Second one, 3 comma 4. See this I have already explained you. It should be y belongs to because 3 comma 4 it is an element. So this is true. In first itself I have explained you. Then this thing, third part. Now they have given. See element when we write inside the curly braces, then it will become set. Now 3 comma 4 is an element of set A. So when I write this 3 comma 4 when it is written inside the curly braces, this is an element. Again we have written it inside the curly braces, then it has become set now. So for set we can use subset symbol, and yes we know it's a subset of set A because it is present in set A, which means this is true or correct. Now 1 belongs to A. 1 is an element. With element we have to write belong symbol. So this is true. 1 is a subset. So 1 is not a subset. 1 it's an element. So this is false. With element we can't use this. Now 1, 2 and 5. 1, 2, 5. See 1 is there in set A. 2 is also there and 3 is also there. If these three elements, if I am writing inside the sorry, if this I am writing inside the curly braces, then it is becoming a subset. So which means this is also true or correct. Then 1, 2, 5. This is subset. Just now we have done in previous subset. We can't write belongs to. It should be written as set, which means this is false. 1, 2, 3. 1, 2, 3. See 1, 2 and 3. This is not a subset because 3 comma 4 this is together. 3 comma 4 is together and 3 element it does not belongs to A. So here we can see in set A, if we are seeing, there we don't have any element 3. We can see all the elements I have written separately. 1 is one element, 2 is element, then 3 comma 4 is one element, 5. A is not an element. So I can't take, that means this set is not a subset of A. So which means if it is not a subset, so this is false. This is incorrect. So you can mention the reason also, because 1, 2, 3 is not a subset. Because 3 element itself does not belongs to A. So that language little bit you can write. The next 5 belongs to. See 5 we used to write this is empty set. It is set itself. We don't have to write 5 inside the curly braces. Since it is a set, with set we can't write belongs to. We always have to write subset, which means this is also incorrect, means false. Now 5 is a subset of A. This is correct. Just now I've explained because 5 is a subset. So subset we can write. An empty set is always a subset of each and every set. Empty set and set itself, they will always be subset of that particular set. Now this thing phi. See, when we are writing subset either we should write as phi or we should write at curly braces. So this is a wrong representation. This is wrong representation. This is not any set. If this is a set, that means this element should be present in set A. And here we can see there is no such element present in set A. All the elements which are present in set A are these elements which I already wrote, which means this is also incorrect or false we can write. So next question number 4th. So write down in question number 4th, write down all the subsets of the following set. So subsets we have to write of the given sets. So first one. So one set is given to us, set is A. This is singleton set because only one element is present. So subsets, if I have to write here, only two subsets will be there. First of all, empty set, and secondly the set itself. This. So these two are the subsets of this set. Because here we don't have any other element. So singleton set will always have only two subsets. Now I have another set now, A comma B. If I have to write its subsets, so all the subsets, first of all, phi will be its subset, then set itself means A comma B I can write, then singleton sets. So set A and set B. So these will be the subsets of this set, and you can also check. You can see here how many elements are there. Here elements I am writing as M for first one. M is equals to 2. If I have to find number of subsets, so I can write 2 raised to power m. So 2 raised to power m means 2 raised to power 1, which is equals to 2. You can see two subsets we have found. Same way for this one, m is equals to 2 because this set has two elements. So that means number of subsets is 2 raised to power m, which means 2 raised to power 2, which means 4. 2 into 2 is 4. So we can see we have 4 subsets. 1, 2, 3, 4. Now third one, set is 1, 2, 3. First of all, number of subsets if you want to find, you can find. Here m is equals to 3. If m is equals to 3, 2 raised to power 3. 2 raised to power m is 2 raised to power 3. 2 into 2 into 2, which is equals to 8. So here 8 subsets we are going to get. So first of all, phi, which will always be there. Then set itself. Itself means 1, 2, 3. Then all singleton sets we can take. So set 1, 2, then 1, 2, 3, 3, then 1, 2 we can take. All with 2, 2 elements we can take. 1, 2 we can take, then 2, 3 we can take. Then we can take 1, 3 as well. 1, comma 3. So we can count now how many? 1, 2, 3, 4, 5, 6, 7 and 8. So that's what we already discussed. So 8 subsets will be there for this set. Fourth one is phi. Phi means what? Phi means empty set. Phi is empty set. Empty set means it does not have any element. So that means in this case m is equals to 0. If m is equals to 0, how many subsets we will get? 2 raised to power m is 2 raised to power 0, which is equals to 1. So any numbers power 0 means this is equals to 1. So it will have only one subset, and that will be phi itself. So with this we have completed question number 4th also. Let's do question number 5th. How many elements has power set of A? Power set. See, P of A means a power set. This is a representation of power set. So this means power set of A. Power set of A. If A is equals to 5, see this is in previous part we have already discussed. If A is equals to 5, that means number of elements of A is equals to 0. It will not have any element. If it doesn't have any element, that means number of subsets, it is 2 raised to power 0, because 2 raised to power m, here m is equals to 0, which is equals to 1. So only one subset will be there, and that will be phi itself. So if A is equals to 0, then only subset is phi itself. So next question is regarding the intervals. So write the following as intervals. So intervals I have told you how to write. So same way we will write. So first one, it's in set builder form is given to us. We have to write in interval form. So very easy. You just have to see first numbers we'll write -4 and 6 is there. So brackets we have to see. Here equality is not there. Only x is greater than. So open bracket, and here equality is there. So which means closed bracket. So this only we have to see. Now again, this is first part. Second part, again two numbers. First of all, write down the numbers given. So 12, -12 and -10 is given. Now with both you can see equality is not there. X is greater than -12 and x is less than -10. So it will be both side open brackets. Open means -12 and -10 are not included, but all the numbers between them are included. Now next one, numbers first of all we'll write 0, 7. So 0, with 0 equality is there. X is greater than equals to. For equality, close bracket. Then x is less than 7 means open bracket. Fourth one, numbers will write 3 and 4. With both equality is there. So with both 3 and 4, closed bracket will come. So this is closed interval. This is again open closed. This is full open interval and closed open. These are semi open or semi closed. You can see. So let's do next question, seventh one. So intervals are given. We have to write in the set builder form. So just opposite to the previous question. So again very easy. So we can just write the interval. Again set builder form we are writing. So x, any alphabet you can write, is equals to x such that x, so both side open. So open means without equality we have to write. So x is greater than -3 and x is less than 0, and you can write x belongs to real numbers, because intervals, they are subset of real numbers. So here particularly you have to mention that x belongs to real numbers. Second one, both closed, 6, 12. So same way is equals to x such that, now closed means greater than equals to and less than equals to. Now 6 and 12 we can write such that x belongs to real numbers. Then next one is this side open and this side closed. And inside curly braces we have to write x such that, again write x in between. Here open means only greater than 6, and here closed bracket is there. Square bracket means closed, so there we have to write inequality, which includes equality as well, less than equals to 12, and x belongs to real numbers. The next one is closed -23, 5 open. So is equals to x such that x is closed means greater than equals to -23 and less than 5. Only less than because it's open, and x belongs to real numbers. So with this, seventh question is also completed. So questions are very easy. Easily we can write. The representations are only there. So we can write this thing very easily. Now next question. The universal set. What universal set would you propose for each of the following? So universal set, I explained you, it's quite a bigger set from which we can choose small sets. Like this, suppose this is a universal set. I took example of real numbers and I explained you, like real number can behave as a universal set, and set of natural numbers or set of rational numbers or integers, they all will behave as subsets. So like this they are telling, for set of right triangles, so what will be the universal set? See, set of right triangles. So universal set, it can be set of triangles. I can write it as universal set for this one x such that x is a triangle, because when I'm writing is a triangle, so it covers every triangle, every type of triangle, whether it is right triangle, whether it is squalene, whether it is equilateral or isosceles, every triangle it is covering. So triangle set can act as a universal set for set of right triangles. Suppose this is a set of triangles. So this is a set of triangles. So all the triangles, I'm writing it as T. So basically we can write it as U because it's a universal set. So it has all triangles. So all triangles means somewhere here smaller set will also exist where only right angle triangle will exist. So that means this set can act as a universal set for this. Also, other than this, you can choose a set of all polygons, because polygons means every type of polygon, closed polygon, you can say it can have quadrilaterals, it can have triangles, hexagon. So set of all the polygons also you can choose. So universal set is x such that x is a polygon, because polygons also includes everything. So from there it can also act as a universal set for set of right triangles. Now next one, second part, the set of isosceles triangles. See, for isosceles triangle also both these can act as a universal set. For this also x is a triangle. This also can act as a universal set for set of isosceles triangle, or x is a polygon can also act. So any one you can write. Now let's do the last question of this exercise. And the last question of this exercise says here three sets are given to us. Set A, set B and set C. We just have to write like which of the following sets may be considered as universal set for all these three sets. So here few sets are given to us. So set A, I'll just rewrite set A is equals to 1, 3, 5. B is equals to 2, 4, 6. And C is equals to 0, 2, 4, 6, 8. So all the elements, I have just rewritten it. So elements, I just have to see. So first set, first set, it has elements 0, 1, 2, 3, 4, 5, 6. So one by one we'll check. So A, B and C, whichever elements are there, everything should be present in this set, then only it can be considered as universal set. So 0 is present in only C. See, in A also and B also it's not present, but see, let's check. So 0 is present here, it's present here also. 2 is present here, here also 0 is present, 2 is present, 4 is also present here, 6 is also present, but see 8 is not present. So set C has 8, but universal set which we are considering, it does not have 8. So that means for C this set cannot act as a universal set. For A and B also let's check. See, 1 is there here, 3 is there and 5. For A it can act, and 2, B also will check. 2 is there in both, 4 is there in 6. But for all the three, for A and B it can act, for all the three it cannot act. So that means this one cannot be considered as a universal set for the given three sets. If they say for only A and B, so this can be considered. 5. See, 5 is the smallest set. So smallest set for these sets cannot be considered because 5 means it does not contain any element. So 5 cannot be considered. Now next one we will see. So next I'll just rewrite once again. So the set has elements. I'll be just writing it as U 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so one by one we'll check. A has 1, it also has 3 is also there, 5 is also there. So A's all elements are present in this set. Let's check for B. 2 is there, 2 is here also, 4 is there in B, here also it's there, 6 is also present. So all elements of B also are present here. Let's check for C. See, 0 is there, 2 is there, 4 is there, 6 is there, and 8 is also there. See, all the elements of A, B, and C are present in this set. So that means this set can act as the universal set for A, B, and C. For A, B, and C. Let's see this one. See, again 0 is not present in this one. That means for C, yes, it's not going to be considered as a universal set for all three. That means if for one it is not there, that means for all three it won't be considered as the universal set. With this we have completed this exercise. I hope you have understood the concept. If you are understanding the videos, you can share it with your friends. And thank you so much for watching the video. I'll be continuing with the next exercise in my next video. Once again, thank you.